Okay, this is Math 2, Unit 12B, Lesson 4, looking at complex numbers here. Okay, a couple things as we get started here just to recall, just things you want to make sure you have in your notes here, is that when we're looking at this, and this is the reteaching form, a couple points you want to keep in mind are that when you have I squared, which is an imaginary number, I squared is equal to -1, okay, just have that in your notes there. The other thing you want to remember is that I is actually equal to the square root of -1. Okay, those are two pieces of information that help you through this lesson here. Remembering that I equals the square root of -1 is going to be helpful when you realize that that's why you have to get an I off of the denominator at some point. On the backside page, you'll have some problems where you'll have something like 3 over I. And the reason you can't leave it like that, like from a previous unit, is you cannot have a radical in the denominator. So that's why we have to clear that and get that out of there. But for now, let's take a look at some of these first problems here for simplifying each expression. To begin with simplifying each expression, we think of these as like terms, we combine like terms. So I have a 2i right here. Because it's a positive, these signs will all stay the same. I also have a negative 2i, which means those will cancel one another out, and I'm left with just a -4 for my answer for number 1. On number 3, I'm going to have to use the distributive property, or if you want to use the box method, you could, but I use distributed, and I'm going to go 4 times 1 is 4. 4 times up 2i is plus 8i. I have 3i times 1 for plus 3i, and 3 times 2 is 6i squared. So at this point, I need to combine my like terms, so I have 4 plus 11i, but I can't leave a 6i squared there. I mean, I could, but I'm not done with it, because I know that I squared is equal to -1. So I rewrite that like this, and I have 6 times a -1, which is -6. When I combine a -6 with a +4, I end up with a -2. Yep, so a -2, and I still have my positive 11i. Typically, we write this with the whole number first and the imaginary second. For number 5, again, distributive property, 3i times 4 gives me 12i, and then 3i times a -I gives me a -3i squared. I squared is equal to, we said, a -1, so I would replace the I squared with a -1, and -3 times -1 is a +3, so I'm left with 3 plus 12i for my solution for number 5. Alright, and number 8, our last one here. This one here, how I wrote all over it, is not distributive, it's just combining like terms. I could rewrite it if I chose to. I have 5 plus 6i. Because that's a positive, these still stay whatever they are. So I have a -2 and a plus 4i. I'm going to combine my like terms. I have a 5 and -2, so that becomes a 3. And I have a 6i and a 4i for a plus 10i for number 8. Let's look over on the back side now. On the back side, they're asking you to find the complex conjugate of each complex number. The way that works is, in the examples above, is let's say example that I had 3 minus 2i. The complex conjugate is going to be to take the first term and keep it the same and reverse the sign of the second, plus 2i. That's all we're being asked to do in this case here. So we reverse the sign of our imaginary number there. So for number 10, this becomes 1 plus 2i. Number 12, we have an I, so it becomes a -I, just reversing the term. Number 14, this becomes 2 minus 3i. The reason we do that is in order to help us solve the problems down here. Write each quotient as a complex number. And there are a couple ways of doing this, but I'm going to show you why they do the complex conjugate way the first way in order to solve these ones here. So let's look at number 16. For number 16, we have 3i. 16, we have 3i over 1 minus 2i. And I'm going to transfer over this piece of paper here so I have a little more space to work on it. So 3i over 1 minus 2i. To solve this one, again, I can't leave an I in the denominator because that actually is a radical -1. I can't have that. I'm going to multiply the top and the bottom by the complex conjugate. 1 plus 2i and a 1 plus 2i on the top. At this point now, because I'm multiplying that, I'm going to have to distribute. So let's start with the top. 3i times 1 is 3i. And 3i times a 2i is a plus 6i squared. On the bottom, we have, let's use distributive property again, we have 1 times 1 is 1. A 1 times a 2i is a plus 2i. And here we have a minus 2i, and that's why we did the complex conjugate, so we can get those to go away. And then a negative times a positive gives me a negative 4i squared. Alright, so moving down from here, what I look at is I say, well, let's replace our I squares with our negative 1s. So this becomes a 3i plus 6 times negative 1 on the top. On the bottom, I had the 2i and the negative 2i, which means those are going to go away, and I'm left with just a 1 minus 4 times I squared, which is, again, negative 1. Alright, so moving forward here, 3i and a 6 times negative 1 is a minus 6 over, and a negative 4 times a negative 1 makes a positive 4, which leaves me then with a positive 5 on the bottom or in the denominator. I could leave it like this, or I could rewrite this and again flip the order around. It should be negative 6 plus 3i over 5 if you want to write that with the imaginary number second. And from there, I could then write this and break it apart as negative 6 over 5 plus 3i over 5, or I could leave it like this. So either one of those answers is fine. Again, check with your teacher just to kind of see how do they want you to write that out. I'm not sure how they're telling you to do that, to leave it like that or like that. It's the same thing. Let's look at number 18. Number 18 is 2 plus 2i over I. So I'm going to write this out over here. So number 18 is 2 plus 2i over I. Double check, make sure I got that right there. Yes, that's right. So here's number 18. Again, I can't have an I on the bottom, so I'm going to multiply. What they're wanting us to do is multiply again using the complex conjugate, so I'm going to multiply by a negative I on the top and the bottom. Okay, so let's go and do it that way first of all. So I'm going to multiply by the negative I. To do this here, an I times a negative I is going to equal a negative I squared on the bottom. And on the top, I distribute that through both parts, so I have a negative 2i plus a negative, or really it's actually minus, sorry about that. We'll do a minus 2i squared. Okay, I need to replace my I squareds with negative 1s, so I have a 2, negative 2i stays the same, minus 2 times a negative 1 on the top, and on the bottom I have a minus, and the I squared becomes a minus 1. That's probably the complicated part of this, is making sure that you just add that minus sign there, because that will make the whole thing on the bottom a positive 1. So up here I am left with negative 2i, and negative 2 times a 1 is a positive 2, over, on the bottom I have just 1. Well, the way to write that the proper way would be to say it's 2 minus 2i to solve that one there. And that's solving it using the complex conjugate. I could also solve it another way, and this would help you too, because it does work. I can do 2 plus 2i over I, and just like a regular fraction, if I want to get that number out the bottom, I could multiply at the top and the bottom by I squared. Okay? By doing that, because I over I is still 1, correct? So I can multiply that, no problem. I end up with something very similar. I end up with 2i plus 2i squared over I squared. The difference here is that when I substitute in my negative 1, I have 2i plus 2 times a negative 1 there. On the bottom I have a negative 1. So far it doesn't look super different if you look kind of top and bottom, except our signs are a little different. I had a negative here, positive there, negative, positive, but because the bottom switches, that changes everything around quite a bit. So this becomes, let's write this over here, this becomes a 2i minus 2 over negative 1. So because that's negative, if I want to change my signs around, okay, and rewrite this here, going here and going here, what is 2i over negative 1? Well, it's negative 2i. And what is negative 2 over a negative 1? It's a positive 2. So if I write that in the proper form, I would reverse the order, and what do I have? 2 minus 2i, which is the same thing I did right there. So there's a couple ways of doing these problems, so just keep that in mind. But the complex conjugate works very well. Last one to take a look at here is number 20. And number 20, it is negative 4 minus I over 2 plus 3I. So check number 20. Yep, negative 4 minus I plus 2 over 2 plus 3I. So again, multiply by the complex conjugate, 2 minus 3I on the top and the bottom, 2 minus 3I. Okay, so now we have to do a lot of distributing here. So I have negative 4 times 2 is a negative 8. Negative 4 times a negative 3I is a positive 12I. Here I have a negative I, so I get a negative 2I. And negative I times a negative 3I is a positive 3I squared. All over 4. And then we have a negative 6I. We have a positive 6I. And we have a negative 9I squared. Now I combine like terms. Let's look at the top first of all. The negative 8 stays a negative 8. 12 and minus 2 is a positive 10I. And then I have 3 times I squared is negative 1. On the bottom I have a 4, and those will go away. Minus 9 times a negative 1 because it's an I squared. So let's work this out here. Negative 1 times 3 is a negative 3, plus a negative 8 gives me a negative 11 in the front, plus 10I. That's my top. And on the bottom, negative 9 times a negative 1 is a positive 9. So 9 plus 4 gives me 13. So again, I could leave it like that potentially, or I could write this as negative 11 over 13 plus 10I over 13. Either way is acceptable with me, but I'm not your teacher. So see what they want you to do. All right, hope that helps. That's a little bit of the reteaching page for complex numbers. Thanks.